In this video, we'll look at the stack structure. We'll define the stack of integer class, inspect it, make sure that it works, and then we'll convert that stack of integer class into a template class so that the stack could hold different data types. Here is the stack of integers class. It has two private data members, the array elements that holds the elements of the stack, maximum capacity of 100. It has another private data member size that gives you the current number of elements in the stack. The stack has a number of functions, including the constructor of the stack. It has a function isEmpty that checks to see whether the stack is empty. Peek will look at the element at the top of the stack and returns that element. Push will push an element on top of the stack, and pop will remove an element from the top of the stack. GetSize returns the size of the stack. The implementation of these functions are all right here. For example, the constructor of the stack will start by the name of the class, followed by the scope resolution, the dots that you see in there, and then the name of the function, stack of integers. The constructor sets the size to 0. The isEmpty function basically checks to see whether size is 0, and if so, returns true. Peek will return the element at top. Push will push an element on top of the stack. It receives a parameter value and pushes it on top of the stack. Pop will remove an element from the top of the stack, and that removal is equivalent to reducing the size by 1. Pop actually returns that removed element as well in this implementation. GetSize, as we discussed, returns the size of the stack. Here's a main function that tests this stack of integers. A stack is declared here, and numbers from 0 to 9 are pushed on top of the stack, and then another while loop will pop the elements from the top of the stack. So running this program should give us basically the numbers inserted into stack. Notice that we pushed 0, 1, 2, 3, all the way up to 9 in the stack. And when started popping the stack, notice that 9 is popped basically. So the elements are popped out of the stack in reverse. So 9, 8, 7, 6. As you know, stack is first in, last out structure, and you can clearly see that here as well. Now we want to convert this stack class that can only hold integer data type into a template stack so that different types could be stored in there. In order to convert it to a template class, we need to go right before the class and use the keyword template, type name T. So we are converting this into a template. Stack of integers, I'm going to leave the name as a stack of integers, but probably we should change it to stack of data rather than stack of integers, but we'll leave the name the same because I don't want to change too many things here. And now the elements of this stack could be of type T. So we need to go through the code and inspect the functions. For example, function peek returns an element, the top element, and that element is no longer an integer, it is T. The isEmpty is returning a Boolean variable, which is fine. We can leave it as Boolean. It's not an element of the stack. Push will have to push a T-type element on top of the stack. Pop will have to return a T-type, not an integer type. GetSize returns an integer. We can leave it like that. The elements of the stack are not integer. They are of the type T. Size can remain as integer. Now, one thing that we have to do here as well is, I think I have this as uppercase. This should be type name. There you go. one thing we have to keep in mind is that all the functions inside the stack has to be implemented as template as well. So I'm going to copy this template, type name T, Control C, and then every single function inside this class has to be implemented as template. And then the name of the class must also be parameterized by this T. So the first function basically is upgraded to a template function. Let's go to the next function. Control V. We turned it into a template function. We now need to make sure that the class is also has the parameter T. Next function is peak. We turn it into a template function. Return type of it should be T. And then parameterize the class name. The next function is push. Turn it into a template function. Parameterize the class name. And also the parameter integer should be turned into T. And next function, Control V. Function is turned into template. The pop returns type T. Stack of integers, the name of the class has to be parameterized with that type name. The rest should be okay. The next function, getSize, is going to return integer, which is fine. Parameterize the class name by T, and the rest should be okay. And finally, we have the main. So let's make sure that everything, I have no red line anywhere, and it looks okay. So now we go to the main. Now this stack of integers is now a template class, not a regular class. So you have to, when you declare your stack, you have to say what type of stack this is going to be. Let's say we start with an integer stack, right? So now that T is basically converted to integer, represents an integer. So we have declared an integer class. Everything remains the same. We can actually run this code and it should work fine. We have an integer class and insert numbers 0 through 9 in the stack, and then pop them and print them. The printout is in reverse. Now I can basically create now stack of integers. That's a very unusual name, but place, for example, string in there. So I have a stack of strings, right? Let's just call it S. Now string, we have to basically bring in the string, # included, string, and I think I have it uppercase here. Yeah, there it is. So there's a string. So I've declared S represent a stack of strings basically. So I can go in there and say s.push and then push a string type in there. Let's say Mary, for example. And I can also push another string in there. Let's say Mike. And one more. Jim. So 3 names are pushed on top of the stack. Right? And I can do pretty much the same thing. I can start with a while loop, Control C. I can go through a while loop, and while stack S is not empty, stack S, pop the elements of it and take a look at what it is. So now the output will basically print in reverse order. It will print Jim, Mike, Mary. That would be the content of string stack S, and then prints out the content of the integer stack. So let's run this. And here is the output, Jim, Mike, Mary, and then the content of the integer stack. So I can declare any type of stack I want. I can go in here and then say or declare stack of integers of character type. I can do that. C, I can go and have a stack of integers of a double type if I want to, and then call it D. I can have a stack of circles, any type I can have. So that is again the power of defining your classes as template class.